Hello, my name is Stefan Santesson, and I want to make a very short and brief presentation of the TSL Trust application developed as a proof of concept by the Swedish Agency for Economic and Regional Growth. This application is used to validate signatures from other European countries within a Swedish validation context or local Swedish validation policy. This presentation will assume that you are familiar with the TSL concept as part of the implementation of the Services Directive. The problem is that a signed document like this signed PDF file here from Hungary does not have a valid signature from the context of a Swedish validation application unless we have the Hungarian root, which we by default do not have. So we want to use the TSL information found from various European countries. In this case, we want to find the information in the Hungarian TSL. So we want to make all this information that is currently not trusted. The timestamp is not trusted and the signature is not trusted because we cannot trust the user certificate or the signer certificate. TSLs are out there currently in machine readable forms. 18 countries have them. Contains over 300 trust services with various certificates, root certificates and identity certificates and CA certificates. If we want to turn that into a validation function, we need to filter this through a policy. The local validation policy needs to determine which out of all of those certificates in a TSL that is suitable for the purpose that we are now verifying a signature. In this policy, we filter out only those trust services and CAs and certificates that we want to trust. And then when we want to repackage those into a form that my standard reader actually can understand and use. This is done through cross-certification. So the original service certificate having a service digital identity in the form of an X509 certificate under a root that we do not trust or do not have, we take the essential information, the key, the identity of the trust service, and the key identifier, and put that into a new certificate that we sign under a Swedish or a local validation route, making the signature suddenly being valid under this local validation context, disregarding all of the original certificates that were shipped with the actual signature from the beginning. So here in this example, we're looking at the same PDF file. It is now valid. The architecture for doing this contains a number of components, everything from the extracting the TSL information in the TSL extractor component and the policy module. These are the two main modules, which uses a CA or creates CAs that can cross-certify these certificates and then export them out to the validation applications in various forms. In this proof of concept, the main tool is the PKCS7 formatted file, which is a bag of certificates that might contain everything from 1 to an unlimited amount of certificates that are very easily imported into applications using this generic file format. So looking at the extractor tool, for demonstration, we start with an empty cache with no information at all, only with a list, the European list of lists. Pushing the refresh TSL data button here will go out on the internet and retrieve the EU list, and out of the European Union list we will find links to various national lists, and this is now being collected from the internet right now. So all the freshest TSL information is now being downloaded into my application using only the link to the EU list as the original resource. And this information is now being collected into the TSL extractor. Since I already have a database here, it's matching my current database of 304 certificates, so there was no updates. But I can see here that here are all the URLs pointing to the various lists. There are PDF lists, human readable form, there are XML lists, there are zipped version of PDF and XML files, and this leads to 18 different TSLs, and we can browse through them through TSL by TSL and look at various information. See that Belgium have one trust service provider. That trust service provider have 3 certificates, and we can look into that data and look closer into these certificates to see what information they contain. And we can look through the various lists this way in order to look through and create the policy for validating signatures. The database records allow me to look through all of these collected certificates regardless of the TSL. We can sort this under territory, but also under service type or service status. So out of this information, we will now create validation policies. So here is my policy creation module. I already have 2 policies here. I have one for all EU certificates for trust service providers issuing public key certificates or qualified certificates under any of the recognized service status that should relate to a valid service provider. I have another policy here that restricts to certificates issued under Hungarian PKI, and only the Hungarian ones. So I can see the territory here is restricted to Hungary, and I can also create new ones if that is something that is needed out of a local context. So for example, here we can create one that is just called all QC, and we could just simply call this the Sweden single point of contact qualified certificate validation route. And here I would limit myself to qualified certificates, and I could also limit myself to validation status requests for qualified certificates. These service types are now included here, and I would say that only those that are accredited would be allowed under this policy here. I would also allow under supervision, but nothing else. And I could accept this policy as easy as that, and I could update and refresh, and now I have 3 policies, all represented by different root certificates. And this one here, the new one, the all QC, only find 161 service providers and service provider certificate that matches these requirements, and they will all be cost certified under this route on one click here if I choose to issue pending cross certificates. Moving to this PDF document from Hungary that fails validation, we can simply import one of those PKS7 files, and in this case I will choose to add the PKS7 file that contains all cross certificates of all Hungarian CAs, and importing those cross certificates into my local validation application, the Adobe Acrobat Reader here, and choose to validate all signatures. The signature will now be valid. And looking at the details, show the certificate, we can see that the appropriate end entity signer certificate is valid under the appropriate service provider, which is now validated under the Sweden single contact cross certification CA that is applicable for this particular purpose. So this TSL Trust Tool is all based on open source. It's created and written in Java. It uses a MySQL database. It uses the Belgian Federal ICT TSL library for parsing TSL information. It uses an OpenSSL CA, uses a tool command language TCL and expect script language. If you want more information, and this video can be retrieved from aa-sec.com/TSL Trust, and other information will be provided there as well, along with the project develops. And feel free to send me an email asking for other information. I hope this information was useful for you, and thank you for watching.